Hi everyone, today we are going to learn the latest version of HCIA cloud computing, and the content of today's lecture is about storage virtualization basics. After having a certain understanding of the types of the lowest physical disk, let's take a look at the storage devices consisting of these underlying physical disks. Storage devices generally fall into two categories. One is centralized storage and the other is distributed storage. First, let's take a look at centralized storage. What is concentrated centrally? These are the physical hard disks in our bottom, which are concentrated in a place called a hard disk basket, where we use these disks directly to the host. Actually not. First, we will do an operation called read on these disks. After the read is completed, a resource pool is formed, and then the resource pool is used for the host, and the host read and write data to this resource pool. What is this read? Read is a technology through the read technology. We can improve the read and write speed of this data. Moreover, we can also improve the security of this data through RAID. Because of the RAID mechanism can perform priority and hot standby technology. This can ensure that our data will not be easily lost and improve data security. These are four commonly used RAID technologies. One is RAID 0, RAID 1, RAID 5, and RAID 6. You may also see RAID 10 and RAID 50. RAID 10 is RAID 0 plus RAID 1. RAID 50 is RAID 0 plus RAID 5. Let's take a look at RAID 0 first. As you may know, the data is usually stored in the hard disks during the running of our computer. When this data is used, this data will be read into the memory, and then the CPU will read the data in the memory. CPU and memory read and write speeds are much higher than disk. It's often found that your computer's CPU utilization is not high. The memory utilization is not high, but the computer is slow. In most cases, your bottleneck is on the hard drive. What should I do with this situation? I will increase the number of my hard drives. Isn't your memory's read and write speed fast? I can read and write at the same time with 10 hard drives. Can I increase the read and write speed of my hard disk by 10 times? In theory, this is the case. But there is a calculation process in between, and the time can't be increased 10 times. But even so, you can greatly improve this read and write speed of the disk. 10 disks or a few disks provide read and write speeds at the same time. This is RAID 0. However, RAID 0 has a problem. If the data on the disk is lost, the entire data is lost. For example, if you usually compress the file separately when compressing files, the maximum attachment of my email is no more than 50 megabytes. I have 100 megabytes file. I want to compress this file into two compressed packages. Once the data of one of the compressed packages is broken, you cannot decompress after you send it to the other party. RAID 0 is also the problem. One of my files is written in 10 copies on 10 hard disks. One of the files can be read, and the entire folder cannot be read. Therefore, also RAID 0 solves the problem of reading and writing data. It cannot solve the problem of data security. Let's take a look at RAID 1 again. RAID 1 comes with data. It will be copied into two copies, and then written separately on two different hard disks. What are the benefits? That is, one of my hard drives is broken, and I have another data stored on another hard drive. Then I can take this bad hard drive and replace it with a new hard drive to do data synchronization, or two identical data. RAID 1 solves the problem of data security, and to some extent it solves this problem of reading and writing. But it also has a problem, that is, the hard disk is too wasteful. I can only mention one hard disk space for two hard drives. Next, let's take a look at RAID 5. RAID 5 adds a technique called parity. The technique is to write a 0, write a 1, and then write a checksum. I can enter that this check value comes out based on 0 and 1. At the same time, I can enter another data based on 0 and the check value, 1 and the check value. What are the benefits? These are the three hard drives which break any hard drive. I can use the data on the other two hard drives to get the data on the broken hard drive. A hard drive is broken. I'm going to do a new data synchronization or refactoring, and then I can recover the data. RAID 5 solves both the security problem and the problem of reading and writing. But there is a problem. If the RAID 5 breaks two hard drives, the data cannot be recovered. Therefore, we have developed RAID 6 on the basis of RAID 5. RAID 6 added a new check value, which means write a data 0, write a data 1, and write a check value, and then write another check value. If you break two disks at random, I can derive the data from the two broken disks based on the remaining two disks. RAID 6 is more secure than the RAID 5, but its resource utilization is worse than RAID 5. There are two types of centralized storage. One is some storage and one is not storage. The difference between them is still quite a lot. Let us give an example. The some storage provides a bare device upwards. That's to say, from the host side, some storage provides a hard disk with nothing, and the NAS storage has a file system, and from the host side is a directory. This is a big difference between some storage and NAS storage. Next, let's take a look at distributed storage. The distributed storage, as its name implies, store all of the physical disks on the different physical hosts. Why do you do that? Normally, we buy a server again. I will bring 4 hard drives, 6 hard drives, 8 hard drives, and so on. But in general, we will make the first 2 hard drives a RAID, and then install the operating system for it. Real data may be stored in centralized storage. In this way, multiple hosts can share this data, and the remaining hard drives are wasted. In order to avoid waste, we put these hard disks that were not used on each host to form a resource pool. Before we doing the resource pool, we have to implement a technique called the copy mechanism. After completing this copy mechanism, a resource pool is finally formed, and then this resource pool is used for each host. That is to say, the distributed storage hard disk comes from each host, and then forms a distributed resource pool, and finally uses this resource pool for each host. Next, let's take a look at the copy mechanism. First, look at how the data is written to the hard disk under the copy mechanism. After a data comes down, it will first be written to this distributed resource pool. This data will be copied into 3 copies at the time of the order. Each piece of data is saved on a different hard drive. That's to say, under the copy mechanism, 3 physical hard disks can provide space for 1 physical hard disk. Of course, this is a 3-copy form, and there are also 2 copies, and there are also 4 copies. The 2 copies of the data will be copied into 2 copies. 4 copies of the data can be copied into 4. This is the writing of data under the copy mechanism. Let's take a look at the reading of the data. When the data is being read, it will not read all the 3 data. It reads one of the data and returns it to the client. If the main data is that the data to read is broken, it will read the second and third data. Why should distributed storage use this copy mechanism? Because it is to improve the securities of the data. A copy of data can be copied into multiple copies. And even one of them is broken, the data will not be lost. However, the copy mechanism will cause a waste of hardware resources, and the 3 hard disks can only provide space for 1 hard disk. In this place, everyone will have questions. Why not use a RAID mechanism? If you have any ideas and answers, welcome to the official forum to communicate with me. In the end, we introduced several common distributed storage products. The first is that SAFE is an open source distributed storage, and second is HDFS in Hadoop. The third is Huawei's Fission Storage, and the fourth is VMware's vSAN, which are our common distributed products. There are 3 parts in this lecture. The first is the overall storage architecture. The second is to introduce several types of disks that are common in the market. Introduce 2 types of storage, centralized storage and distributed storage, and their corresponding RAID technology and copy mechanisms. This is the end of today's lecture. Thank you.